Good morning, students. Last class we are discussed about phosphorus chlorides. So mainly phosphorus trichloride. So phosphorus trichloride preparation and the physical properties and some chemical properties also. So now today topic we are discussed about preparation of PCl 5 phosphorus pentachloride and physical chemical properties of phosphorus pentachloride. So how it is prepared? Overall preparation of PCl 5. So preparation of PCl 5 phosphorus pentachloride. Now first we have taken phosphorus. This phosphorus reacts with chlorine. Phosphorus reacts with chlorine to form PCl5. Okay, phosphorus reacts with chlorine to form phosphorus pentachloride. So it is a very easy and important reaction. So phosphorus reacts with chlorine to form phosphorus pentachloride. And next second one, suppose we have taken phosphorus. So this phosphorus is reacts with sulfonyl chloride. This phosphorus is reacts with sulfonyl chloride to form in this reaction. So PCl5. So phosphorus pentachloride and next second one SO2 sulfur dioxide. Okay, SO2 sulfur dioxide. When phosphorus reacts with sulfonyl chloride SO2Cl2 to form phosphorus pentachloride PCl5. Next second one SO2 sulfur dioxide. Okay. Next third one, when we have taken PCl3 phosphorus trichloride. This phosphorus trichloride is reacts with chlorine to form PCl5 phosphorus pentachloride. Okay, phosphorus trichloride is reacts with chlorine to form phosphorus pentachloride. Okay, so they are all preparation of PCl5. Okay, listen. So phosphorus pentachloride is formed by when phosphorus is reacts with chlorine to form PCl5. Or phosphorus is reacts with sulfonyl chloride to form phosphorus pentachloride. Or suppose phosphorus trichloride is reacts with chlorine to form PCl5 phosphorus pentachloride. Overall, what is the physical properties of PCl5? So overall, PCl5 is just like a yellowish, just like a powder, yellowish powder, just like it is a solid compound. Okay, no smell, so yellowish color. So overall it is powder. So which state? Solid state. Okay, so it is soluble in water molecules to form different types of compound. Suppose PCl5 is reacts with a water molecule to form POCl3. POCl3 means phosphorus oxy trichloride. POCl3 means phosphorus oxy trichloride. Next second one HCl hydrochloric acid. Okay, so when phosphorus, it is very important reaction. Write the reaction of PCl5 PCl3 with the water molecules. That is very important question. So phosphorus trichloride reacts with water molecule to form POCl3 phosphorus oxy trichloride and next to hydrochloric acid. So this POCl3 phosphorus oxychloride is reacts with water molecules to form H3PO4. Okay, so remaining 3 hydrogens chlorine to form HCl, hydrochloric acid. Okay, so POCl3, phosphorus oxy trichloride, is reacts with water molecule to form H3PO4. H3PO4 means phosphoric acid. H3PO3 means phosphorus acid. So it is also called orthophosphoric acid. Okay, orthophosphoric acid. Okay, so it is physical properties of PCl5. And next, what is chemical properties of PCl5? So PCl5 reacts with a number of components like a acetic acid or ethyl alcohol, some metals also. So like a silver metal or tin. Okay, number of components. So now suppose for example we have taken CH3COOH. So CH3COOH means acetic acid. Okay, CH3COOH means acetic acid, or it is also called ethanoic acid. So how many carbons? 2 carbons. COOH functional group, carboxylic functional group, oic water. So overall ethanoic acid. This ethanoic acid is reacts with the PCl5, phosphorus pentachloride. Okay, to form CH3CO, 1 chlorine. So CH3COCl. Okay, CH3CO, 1 Cl. CH3COCl means acetyl chloride. Okay, acetyl chloride. Next further POCl3. So POCl3 means phosphorus oxy trichloride. Okay, POCl3 means phosphorus oxy trichloride. Next one hydrogen, 1 chlorine to form HCl, hydrochloric acid. Okay, so when acetic acid is reacts with PCl5, phosphorus pentachloride, so to form in this reaction acetyl chloride, CH3COCl means acetyl chloride. Next POCl3, phosphorus oxy trichloride, and next hydrochloric acid, HCl. Okay, so this reacts with acetic acid, or suppose it is reacts with C2H5OH. C2H5OH means ethyl alcohol. So this ethyl alcohol is reacts with PCl5, phosphorus pentachloride, ethyl alcohol. So ethyl alcohol is also called ethanol. What is the IUPAC of alcohol function group? All word, ethanol. So this ethyl alcohol is reacts with PCl5, phosphorus pentachloride. So to form in this reaction C2H5Cl. So ethyl chloride. Next further POCl3. So POCl3, phosphorus oxy trichloride. Next further one hydrogen chlorine to form HCl, hydrochloric acid. So ethyl alcohol. So this ethyl alcohol is reacts with the PCl5, phosphorus pentachloride. So to form in this reaction ethyl chloride, C2H5Cl, ethyl chloride, and next one POCl3, phosphorus trichloride, next HCl means hydrochloric acid. Okay, so overall third one, it is reacts with silver metal. So silver is reacts with PCl5. Okay, silver is reacts with PCl5. So to form 2AgCl. So silver chloride. Next further PCl3, phosphorus trichloride. So silver reacts with PCl5, phosphorus pentachloride to form PCl3 phosphorus trichloride, and next silver chloride. Okay, so next further Sn tin. So the tin is reacts with PCl5. PCl5 means phosphorus pentachloride. So to form in this reaction SnCl4. So tin tetrachloride. SnCl4 tin tetrachloride. Next further 2PCl3. So phosphorus trichloride. Okay, so overall tin reacts with the phosphorus pentachloride PCl5 to form tin tetrachloride SnCl4. Next phosphorus trichloride. So they are all chemical properties of PCl5. Okay, so PCl5 reacts with acetic acid to form main compound acetyl chloride. Next ethyl alcohol also reacts with PCl5 to form ethyl chloride. Next silver is reacts with PCl5 to form silver chloride and phosphorus trichloride. Next tin is reacts with PCl5 to form tin tetrachloride, and next further PCl3 phosphorus trichloride. Okay, so these are all chemical properties of PCl5. So what is the structure of PCl5? So structure of PCl5. In PCl5 central atom phosphorus. So what is the ground state electron configuration? Outer shell 3s2, 3p3, 3d0. So we write 5 orbital, 3s orbital contain 2 electrons. So 3p orbital contain 1 single electron. So 3d 0. So it is a ground state. In excited state, 3s orbital of 1 electron is jumped to 3d orbital. Okay, so it is a ground state. From ground state, 3s orbital of 1 electron is jumped to 3d orbital. So it is called excited state. So in excited state, phosphorus contain total 5 single electrons. So each chlorine atom contains 1 single electron. 5 chlorine atoms contain 5 single electrons. These 5 single electrons is bonded with the 5 single electrons of phosphorus atom to form PCl5. Okay, so overall sp3d1 hybridization. So what is the hybridization of phosphorus? sp3d1 hybridization. Okay, so overall it's contain total 6 bond pairs. 6 what is the structure of PCl5? Phosphorus is the central atom. So 3 chlorines attached with 3 corners. 3 chlorines attached with 3 corners. So it is a triangle. Okay, trigonal. Overall, another 1 chlorine is attached with the above and another chlorine attached with the below. So it is a trigonal bipyramidal shape. Trigonal bipyramidal shape. So overall structure of PCl5, phosphorus pentachloride, central atom phosphorus. So what is the ground state electron configuration? 3s2, 3p3, 3d0. So in ground state it contains only 3 single electrons, 1 pair. From 3s orbital to 3d orbital, 1 electron is jumped from 3s orbital to 3d orbital. So overall in excited state it contains 5 single electrons. So for each chlorine atom contains 1 single electron, 5 chlorine atoms contain 5 single electrons. Okay, so overall to form PCl5 it contains sp3d1 hybridization with a trigonal bipyramidal shape. Okay, so it is a PCl5 So chemical properties, structure and preparation. So next further, phosphorus very important compound, that is pH3. So pH3 means phosphine. pH3 means phosphine. So how it is prepared? When we have taken P for phosphorus, so this phosphorus is dissolved in sodium hydroxide solution. So phosphorus is dissolved in sodium hydroxide solution. Already we know that this equation. Okay, white phosphorus is dissolved in sodium hydroxide solution. To form in this reaction, pH3 means phosphine and next further NaH2PO2. So NaH2PO2 means sodium hypophosphite. Okay, sodium hypophosphite. So it is one of the best preparation of phosphine. This equation very important equation for exam point of view. So overall phosphorus is dissolved in sodium hydroxide solution to form phosphine and next NaH2PO2, sodium hypophosphite. Next second preparation when we have taken Ca3P2. Ca3P2 means calcium phosphide. So this calcium phosphide is reacts with water molecules. Calcium phosphide is reacts with water molecules to form overall pH3. So pH3 phosphine. Next further CaOH taken twice. CaOH taken twice. So calcium hydroxide. Okay, so when calcium phosphide, so this calcium phosphide is reacts with water molecule to form calcium hydroxide and next for the second one phosphine. So next third one as the Ca3P2. So Ca3P2 means calcium phosphide. This calcium phosphide is reacts with HCl. So HCl means hydrochloric acid. To form in this reaction pH3 phosphine, P2 and the next 6 hydrogens 2pH3 phosphine. Next further, so CaCl2 means calcium chloride. Okay, so calcium phosphide is reacts with HCl hydrochloric acid to form phosphine and the next calcium chloride. So at the same time, this phosphine is formed by phosphonium iodide or phosphonium bromide, any one compound. Okay, so pH4i. pH4i means phosphonium iodide or pH4br means phosphonium bromide. When this phosphonium iodide is reacts with KOH means potassium hydroxide. KOH potassium hydroxide to form Ki potassium iodide. Next further, so pH3 phosphine and one hydrogen OH to form water molecules. Okay, so it is a fourth preparation of pH3 phosphine. Okay, so overall white phosphorus is dissolved in sodium hydroxide solution to form phosphine. Next calcium phosphide is reacts with water molecule to form phosphine. Next calcium phosphide is also reacts with hydrochloric acid HCl to form phosphine. Next phosphonium iodide is also reacts with potassium hydroxide to form phosphine. These are all two preparation of phosphine. Okay. So what is the physical and chemical properties of phosphine? Overall, so this phosphine is just like colorless compound, colorless, and it is a gaseous compound, gaseous compound. And next further it is just like a fish smell. Okay, so phosphine contain which smell? Fish smell. And at the same time it is a highly poisonous gas. Okay, it is a highly poisonous gas. Okay, so overall it is a gaseous compound, colorless, and fish smell. At the same time it is poisonous gas. Okay, so what is the chemical properties of phosphine? Phosphine also reacts with a number of components. Like suppose for example, so this phosphine pH3 is reacts with Hi, hydrogen iodide. Or suppose this phosphine is reacts with HBr, hydrogen bromide. So to form pH4i, pH4i means phosphonium iodide. pH4i means phosphonium iodide. Next further to form pH4br, phosphonium bromide. So when phosphine is reacts with hydrogen iodide to form phosphonium iodide. When phosphine is reacts with HBr, hydrogen bromide to form phosphonium bromide. Next one, so this phosphine is reacts with the CuSO4. So CuSO4, copper sulfate. This copper sulfate is reacts with the pH3 phosphine to form Cu3P2. Cu3P2. So copper phosphide, and next further, so to form H2SO4 sulfuric acid. Okay, so copper sulfate is reacts with phosphine to form Cu3P2 copper phosphide, and next H2SO4 sulfuric acid. Next one, so it is reacts with HgCl2. HgCl2 means mercury chloride. HgCl2 means mercury chloride. So this mercury chloride is reacts with pH3 phosphine. So to form Hg3P2 mercuric phosphide. Hg3P2 mercuric phosphide. Next further in this reaction, HCl hydrochloric acid. Okay, so phosphine is reacts with hydrogen iodide or hydrogen bromide to form phosphonium iodide or phosphonium bromide. So copper sulfate is reacts with the phosphine to form copper phosphide and H2SO4. So mercury chloride is also reacts with pH3 phosphine to form Hg3P2 mercuric phosphide and the next hydrochloric acid. Okay, so what is the structure of pH3? So overall, suppose for example, so pH3 central atom phosphorus. So overall central atom phosphorus, it is attached with 3 hydrogens with a single bond. So phosphorus contain one lone pair. This lone pair is indicated with the orbital. So overall it is a pyramidal shape with a sp3 hybridization. Okay, so pH3 phosphine central atom phosphorus. What is the electron configuration in outer shell? 3s2 3p3 3d0. So 3p3, so it's contain 3 single electrons. So each hydrogen contain one single electron. 3 hydrogen atoms contain 3 single electrons. These 3 single electrons of hydrogen atoms is bonded with 3 single electrons of phosphorus atom to form pH3. So it has one lone pair and three bond pairs. One, two, three. Three bond pairs and one lone pair. So it has sp3 hybridization with a pyramidal shape. Okay, so it is a phosphine, preparation of phosphine, and next chemical physical properties of phosphine and structure of phosphine. So what is the use of phosphine? So phosphine is mainly used for to preparation of different types of compounds like a phosphonium iodide or phosphonium bromide. At the same time, copper phosphide or mercuric phosphide. Okay, so to form preparation of different types of compounds. Okay, so it is p block elements. Next further we are discuss another lesson.